next topic is categorical independent variables. So far we have looked at independent variables that were continuous variables. But what if we have a variable that takes categorical values, meaning whether the observation belongs to a particular group, like if you talk about majors in college, whether it is accounting major or marketing major or entrepreneurial major. So you're not going to have numerical values in this column, but you will have the name of the group. One more example would be like gender. Is it male or female? So when you have categorical variables, and that can be converted into a set of dummy variables, and then it can be included in the regression. A dummy variable is one that takes only two possible values, 0 or 1. 0 represents that the observation does not belong to that particular category for which the dummy variable is defined. 1 represents that the observation belongs to the category for which the dummy variable is defined. Now let's look at a simple example first. The example is Johnson's Filtration Company. Let's look at what this example is about. This company sends maintenance teams for servicing their filtration system. So to estimate the service time and the service cost, the company is developing a regression analysis. So the variables of interest here are the repair time. That is what we are trying to predict. So that will be our dependent variable. And the company believes that the repair time is dependent upon two other variables. How many months has it been since the system was last serviced, and what kind of service problem do we have now? Is it a mechanical problem or an electrical problem? See, the second variable is a categorical variable, whether the service problem is mechanical or electrical. So let's look at how we're going to deal with this. So the dependent variable is repair time in hours, and the independent variables, we have two of them. X1 is number of months since last service, and X2 is the type of repair, which is mechanical or electrical. So we're going to code mechanical as 1 and electrical as 0. So now we'll go to Excel file and set this up. So here we have the repair time here, months since last service, and the repair type. So now let's define the dependent variables. Y is repair time in hours. The first independent variable is months since last service, and the second independent variable is type of repair. Now we have to recode the second independent variable into a dummy variable. We'll recode X2 into 1 for mechanical and 0 for electrical. The last service is the same. Time is the same. The type, we're going to use a if function. If that is equal to mechanical, then code it as 1, otherwise code it as 0. So if it is electrical, it will be 0. Okay, now we have the data set up. Let's run the regression. Now Y is this. Now the X range is this. The labels. And let's put the output right here. And format. So now here are the coefficients. So let's set up the estimated Y. So that will be equal to 2.19 plus 0.39 X1 minus 1.26 X2. So now we can set up a y hat equation for electrical separately and mechanical separately. Remember, if except 2 is 0, then that will be electrical. So that means that part is gone. Y hat will be just that part. There it is. But if you substitute except 2 equal to 1, then you get 2.19 minus 1.26 will be the y-intercept, and that will give us a second equation for mechanical repair. Now let's look at interpretation. B sub 1 is 0.39, and that's in hours. So if you want to change that to minutes, you can take that and multiply by 60. So that will be minutes. So the interpretation follows the same logic as before. So for x sub 1 is number of months since last service. So for each additional month that passes, your service time will increase by 23.3 minutes, provided the caveat being the repair type being the same. Now B sub 2, which is minus 1.26, you have to be very careful interpreting this coefficient. You can't say if type of service increases by 1, because that doesn't mean anything. That's absurd. So here the type of service is either mechanical or electrical. So if it is 0, it is electrical, and if it changes, if it increases by 1, that would mean from going from electrical to mechanical. So if you go from electrical to mechanical, then this is what will happen to service time. In other words, service time will go down by 1.26 hours, so which is 75 minutes. So the service time, if type of service is mechanical, is 1.26 hours or 75.8 minutes, less than if the type of service is electrical, with number of months since last service being the same. So interpreting dummy variable slope coefficients, you should be very, very careful.